I don't know how to write theta. I'm going to use a different. I'm going to use sine of A. Maybe sine B. Okay. I'm just going over the basic trig functions. I think I did everything right there. So these are the 6 basic trig functions. The first 3 we can get from SOHCAHTOA. And that basically means sine is equal to opposite over hypotenuse. And then cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. So this is the opposite. Y is the opposite angle from B, or the opposite side, and then Z is the hypotenuse, and X would be the adjacent side to B. So that's just some basic, like the very basic of trig. Now, do we have like the homework list for the ready yet?
She put the link in the chat.
Okay, good. Okay. So any particular problem you want me to do first? Or do you just want me to just go through the homework problems? Okay. So let me just. Okay, let me find the first one. Okay. So I see the first one is sine x from 0 to pi. Okay, so we have 0 to pi of sine x dx. Okay. And so does anyone know what the integral of sine x is? Or what we would take the derivative of to get to perfect, be cosine, right? Because let's see. Let me put this over here. Derivative of cosine x is equal to negative sine. So going backwards, if we have sine x, well, then the integral of that is going to be cosine. But remember, we have a negative, right? So it's going to be negative cosine x, evaluated from pi to 0. And remember, we could put the plus c in here too, if you're wondering where the plus c is, but when you evaluate it from pi to 0, the c will cancel out. And so we get negative cosine of pi minus the function evaluated at 0. negative cosine of 0. Okay, so from here, we have to go to unit circle. Okay, and so when you use unit circle, cosine of pi, you can actually look at the graph too. So I'm not sure if you're familiar with the graph. This is the graph of sine. So it starts at starts at 0. This is 1 here at pi over 2. This is -1. So cosine, but this is the graph of cosine. Let me erase this. So this is a graph of sine. So this is pi over 2. This is pi. The graph of cosine is the same graph as sine, but it starts up here. And so this is at pi right here. And it's at -1. Okay, so when you look at the graph, cosine of pi is actually right here. And so the value of cosine of pi is negative times -1. And can you tell me what the value is of cosine of 0? Oh yeah, you're right. Oh yeah, so this is yeah, this becomes a positive 1. And then these two negatives become a positive. And the cosine of 0, if we take a look at the graph, is 1. So we get 1. So the value of this integral turns out to be 2. Okay. So Alfonso, Atani, Javi, can you give me like 1 through 3? I know, Javi, you came in a little late, so you might have started from when we were in the middle. Okay. 2.8? Oddly specific. Okay. So let's do the next one. I'm going to see if I can paste the unit circle. You know, here's what I'll do. I'm going to clear these drawings. I'm going to find a unit circle website. If you're ever trying to learn math, Math is Fun is a great website. So I'll post that in the chat. And using the values, if you scroll down to 30 degrees, 45 degrees, 60 degrees, those are the important angles. And then from there, you can get to the whole circle at the very bottom, or close to the bottom. Okay, so now we'll do the second problem here, and we'll make sure that we have the unit circle all good to go. So the second one is from 0 to pi over 3 of 2 secant squared. d theta. And remember, because our variable is theta, we need a d theta because we're integrating with respect to theta. Okay? Does anyone remember what derivative we would take to get to secant squared? We know
Tangent,
sine.
right?
I didn't hear what you said. Sorry. I think you said tangent, right?
Yeah.
Okay. Yeah, so that's correct. So we know sine and cosine are related, right? When you take the derivative or integral, you either get sine or cosine with a negative or positive, right? If you take derivative of sine, you get cosine. Take derivative of cosine, you get negative sine. And, you know, we can go backwards and forwards. But the other four trig functions are a little bit more difficult. Right? Derivative would be going this way. And then integrals goes this way. But derivative of tangent is equal to secant squared. And this is just something you're going to have to memorize if you have not done so already. Okay, so from here, we can take what we can do by rules of integrals. We can take the 2 outside because it's just a constant. And we're left with just secant squared. And as Javi pointed out, or I believe that was Javi, the integral of secant squared is tangent. And we have to evaluate this from 0 to pi over 3. Okay, so does anyone know how many degrees pi over 3 is? If you want to convert pi over 3 to degrees, how many degrees would that be?
60?
60? Do we agree with the Tani?
If it's on the unit circle, yes.
Yeah, so even if it's not in the unit circle, in math, you know, in the real world, we use degrees a lot, but in the math world and in more engineering aspects, right, in the professional math world, they'll use radians. And actually, calculators default to radians too. So pi over 3 radians is always equal to 60 degrees. Now, technically, like if you keep on adding 360, you get to the same 360 degrees or 2 pi radians. You get to the same point with just an additional revolution. But yeah, so pi over 3 is 60. So this is 0, pi over 2 up here, pi 3, pi over 2. And as I was saying, this is 2 pi. 2 pi equals 360 degrees. If I could write that a bit better. And the point I was trying to make before is that this is also 4 pi and 6 pi. If you keep on you can keep on adding 2 pi And so pi over 2 is also 5 pi over 2. And this is, 3 pi. But we don't need to worry about those. Just know that if you keep on adding 2 pi, the angle's the same. But in this case, the midway point between 0 and pi over 2 is pi over 4. So pi over 4 is equal to 45 degrees. And then pi over 3 is equal to 60. Everyone following me? We good to go on like what each of the radians equals to in degrees? Yes-ish? Is there something I can explain a bit better for you, Javi? Okay, so I put in, if you look up unit circle, it'll give you a unit circle. I put in like a article from Math is Fun that kind of goes over how to get the unit circle. I'll just put it in the chat again. If you scroll to like towards the bottom, it will give you the entire unit circle. And maybe, I'm not going to open that at the moment, but I'm assuming Alfonso put in a screenshot, the unit circle. Okay. Thank you, Alfonso. So we are evaluating from 0 to pi over 3, right? And most of the time, unit circle is just going to be in radians, but I just wanted to make sure you knew what that meant in terms of degrees, because it's easier to understand sometimes. So if we look at the unit circle, a lot of times the unit circle will tell us what sine or cosine is equal to. And the unit circle, how it works is it'll have, I'll use this same one actually. So let's just take a look at pi over 3, okay? The unit circle will tell you that this point is 1/2 square root of 3 over 2. And the reason why it's called a unit circle is because the radius is 1. That's why it's called a unit circle. Everywhere along the circle, this circle, it has an R of 1. Pretend that my line goes to the edge of that circle. Or maybe I'll just draw a better line. Okay, what we can do is we can draw a right triangle with this being 60 degrees, theta. Theta is 60 degrees. And we know from the unit circle that this, I'm going to draw it bigger. We're going to take this triangle here. We have theta is equal to 6, I'll use pi over 3. We have pi over 3 radians. Right? And because of this, we know the point is 1/2 square root of 3 over 2. We get an x value of 1/2. Right? Because you can see from this x value that it goes to this point down here. And for the same reason, we get a y value of square root of 3 over 2. and our radius is 1. Now this is kind of complicated if you're not that familiar with unit circles, so please let me know if I'm going a bit too fast. Or you're having a bit of trouble understanding it. So can I get a 1 through 3 in chat from everyone? Okay. My Spanish is bad, but I know that one. This is complicated, so please let me know if it's if you're having trouble, a little bit of trouble with it. 2, okay. Thank you, Atani. Where are you at, Javi? Is that the Chinese symbol for 3? I think that's the Chinese number for 3. Those are the only 3 numbers I remember for China, in China, Mandarin. Okay, so Atani, how can I support you?
Cause I was just gonna be like, is all that like necessary for the problem? Like, when you just look at the unit circle and then find that number and then just plug it in to find the
Yeah.
answer?
So sometimes a unit circle will give you sine and cosine, but it won't give you tangent. And I'm just kind of trying to show you where the unit circle comes from. And so I'm just about getting there. Because if you just memorize the unit circle and don't realize like why it works like this, then you'll have a harder time later on and on the test. So is there anything else that I can help you with? I only know like the numbers of each. I mean, it's not an accomplishment to know what 3 is in Spanish, but thank you. I appreciate it. Okay. Well, I guess it is an accomplishment, but my Spanish is awful. Okay, I'm going to, because you mentioned that, yeah, we can just plug in, and you're correct. But we can't just plug in 1/2 or 3 square root of 3 over 2, right? Because what the 1/2 represents, if we remember, what would sine, let's talk about sine and cosine for a minute, and then we can talk about tangent. Sine is opposite over hypotenuse. The reason why the unit circles work so well is the hypotenuse is always 1. And so we just take the opposite, which is our y value, and we just get an answer of square root of 3 over 2. And it works the same way with cosine. Where you have adjacent. And again, this is from SOHCAHTOA. But you don't need to use SOHCAHTOA if you can't, if you've already memorized it otherwise. Our adjacent one is the one closest. And again, our hypotenuse is always going to be 1 on the unit circle. And you just get 1/2. So the whole point of the unit circle is that our x value is always our cosine. And our y value is always our sine. Because the hypotenuse is always 1. Now when we get to tangent, the units, they might give you, I'm not sure if they'll give you the unit circle for some problems, but even then they might only give you the sine and cosine. Sure. It's a bit difficult. Yeah, why don't you tell me later which steps you want, because I'm kind of going over like a couple different things. But yeah, I can do that for sure. So tangent is a bit different. It's tangent's equal to sine over cosine. If you just look at SOHCAHTOA, you also know that it's equal to opposite over adjacent. And so our opposite over adjacent is the same thing as our sine and cosine, because the opposite square root of 3 over 2, but that's also equal to our sine. Our adjacent is 1/2. Is also equal to cosine. So we get square root of 3 over 2 all over 1/2. And so when you simplify that down, the 1/2s cancel and you get square root of 3 is equal to tangent of pi over 3. Depending on the unit circle you have, they might just give you the value for tangent of pi over 3. But this way that I'm showing you saves you from having to memorize all the tangent values. If you know that tangent is sine over cosine, then all you have to do is memorize the sine values. If you memorize the sine values and the cosine values, you never have to memorize the tangent values, because you can just put tangent sine over cosine and do it that way. But tangent of pi over 3 is equal to square root of 3. Okay? And we can also look at the unit circle here with tangent of 0. Well, the value for 0 radians is 1, 0. And so our sine of x is actually going to be 0. I'll put 4 0 radians. Let me actually put it in the text box. 4 0 radians, sine of x equals 0, and cosine x equals 1. Hold on one second. I don't know how to get rid of this one little s here. I'm going to rewrite that. 0 radians, sine of x equals 0, cosine of x equals 1. So if sine is 0 and cosine is 1, what's tangent going to be equal to? Javi, do you agree with Alfonso?
Yeah.
Yep, perfect. So like I said, at an angle of 0 radians, which is here. I don't know why I can't draw a straight line. We get the point 1, 0. And so tangent of 0 is 0. Okay. And I know I kind of went off into the unit circle, but I know a couple people didn't take pre-calculus, maybe didn't learn the unit circle, so I wanted to have a review for that. It's going to be very useful in the coming weeks. You can't run from trig, unfortunately. Okay, so if we go back to the original problem, I'm going to erase all this. Okay, if we go back to the original, we can evaluate 2 tangent of pi over 3 minus 2 tangent of 0. Okay, tangent of 0 is equal to 0, so that just gets canceled out. Tangent of pi over 3 is square root of 3, so we get 2 times square root of 3 as our answer.
You know that thing when you look at a problem and then realize that you understand it completely now, and it just comes all at you.
I'm dreading what you're saying next.
Like you just completely figure out how to do it now, even if it's like a different situation.
Okay, are you gonna say you don't know that feeling, or you know that feeling?
I just felt that feeling.
Oh, okay, that makes me feel really happy. That's awesome. Why do you keep changing fast foods? What's the 0? Oh yeah, that was from before. What's the changing fast foods? Oh, I have the chat over to profile pic. Burger King's all right. I like their chicken sandwiches there, but not my favorite fast food place. Okay, so that I'm very happy to hear that, Javi. I wanted to go over unit circle just because a lot of people, it kind of scares them, but at least I'm saving you from having to memorize all the tangent values. If you can memorize the sine and cosine values from unit circle, then you can get tangent by doing sine over cosine. Alfonso, how are you feeling about this? Hey, Atani. Okay, so let's just do another problem. What's the next one? Okay. How many degrees is pi over 4? Just as a quick test. And 3 pi over 4? Do we agree with Atani that 3 pi over 4 is 60? Do we agree with Alfonso?
I agree with Alfonso, but I think Atani's right if you were to look at it, and I'm not sure how to say it.
Well, if pi over 4 is 45, 3 pi over 4 is going to be 3 times that, right? It's all good.
So it's 135 and 45, right?
Yeah, it is. Atani, you got the first one, which is 45. So if you can get that, you can get 3 pi over 4 because it's just 3 times that value, right? Because you're just multiplying pi over 4 times 3. So Okay. So, do we remember what derivative we need to get that answer? I don't think you do. I think you need to memorize the, I'm almost positive you do not get a unit circle. So you need to memorize that. But like I said, I was trying to show you a trick so that you wouldn't have to memorize tangent values. You just need to memorize the coordinates. If you memorize the coordinates, it gives you sine, it gives you cosine, right? Because all the x values on the unit circle are your cosine values. All the y values on the unit circle are your sine values. And then from there, you can get your tangent by just doing sine over cosine. Just to go over it again very briefly, we have our theta. On the unit circle, the hypotenuse is always 1. And so we'll have our x value. The point's up here, right? And we have the origin. And so our x values here, our y values here. Our sine is always going to be our y value because it's opposite, which is this, over hypotenuse. So, and the same thing for cosine. So we get an xy value. Our sine values are always going to be y. And our cosine is just going to be x. But that's just an example. Well, all you have to do is memorize the coordinates. You can get sine, cosine, and tangent from the unit circle. So if you just memorize the x and y values of the, and all you need is actually the first quadrant. If you can get the first quadrant, then you can apply it to the other quadrants too. So just focus on learning the first quadrant here. So you need to learn 0. Here, let me just put this. You need to know 0, pi over 6. I'm actually going to put it in degrees because I can't type a. These are the angles you need to memorize for unit circle. Okay, so that's what you'll need to know for the AP test. If you have those 5 angles, 0, 30, 45, 60, and 90, you can get all the rest of these. By just multiplying by a negative. So for instance, let's take 60 degrees. We have 60 degrees again, right? You do get a sheet? Oh, I didn't get one while I was taking the AP test. Okay. Well, I'm going to have to confirm with Miss Rose, but if you do get it, so let's see. This is pi over 3. Two pi over 3 over here. The coordinate for this is the same thing, but because it's in the second quadrant, the x-axis is negative. You get negative 1/2. and square root of 3 over 2. So just because it's in the second quadrant doesn't mean it's different. And it works the same way in the third and fourth quadrant. But the same, it's instead of pi over 3, 2 pi over 3, all of a sudden it's the second quadrant. You still get 1/2 and square root of 3 over 2, but you just have to remember, because it's in the second quadrant, the x coordinate's negative. So it's the same numbers. You just have to make sure that depending on what quadrant you're in, you make it sure that it's either positive or negative. So down here, 4 pi over 3. You get negative 1/2 and negative square root of 3 over 2, because it's in the third quadrant and both x and y is negative. Does that make a little bit of sense? Or is this like really confusing? Can I get like some responses, or like a 1 through 3 in chat? Okay. Thank you, Atani. Okay, so back to this. Cosecant, cotangent. What do we remember what derivative we'd take to get cosecant, cotangent? Seems like we're struggling remembering this one. So I'll just write it here. Yep, it was cosecant. And so actually the derivative gets us a negative cosecant, cotangent. So when we consider this, the antiderivative of cosecant, cotangent is actually going to be negative cosecant. Because when we take the derivative of this, we have to cancel the negatives out, because this is a positive. And we need to evaluate it on 3 pi over 4 to pi over 4, or pi over 4 to 3 pi over 4. Okay, so this is where we don't have to memorize all 6 trig functions. Can we get this in a form that is only sine or cosine? Can we simplify this so that we don't have to bother with cosecant, and we can? Okay. What is cosecant equal to? Do we know what cosecant's equal to, so we don't have to? It's 1 over and Javi is correct. It is 1 over something.
1 over negative sign?
So yeah, negative cosecant is equal to 1 negative 1 over sine. We never want to be dealing with cosecant, secant, cotangent. We don't want to be dealing with those other 3. We can, sometimes we have to, but most of the time we can convert it into sine, cosine, and tangent. And even tangent, we don't really want to be working with, we can say tangent's equal to sine over cosine. And so now that we have it in terms of sine, we can evaluate this a lot more easily. Okay, so can someone tell me on the unit circle what sine of 3 pi over 4 is? Can someone take a look at that unit circle?
Radical 2/2.
Great. What about pi over 4?
Same thing.
It is the same thing. You notice how pi over 4, 3 pi over 4, just like I was saying here, it's actually the same coordinates. It's just, they can either be negative or positive. If you took 5 pi over 4, sine of 5 pi over 4 would just be negative radical 2/2. So this is why you only need to memorize the first quadrant. So this becomes a positive here. And so we get negative and we get square root of 2/2 plus 1 over square root of 2/2. And if we want to get rid of the radical, actually, this is just 0. We don't even have to simplify. Yeah, it's just 0. So that's our answer. We good on this? Javi, Atani?
Yeah.
All right, great. So, Alonso, I know you wanted written steps. What part did you want written steps for? The integral itself, the unit circle part of it, or because you don't necessarily have to. I showed you how to evaluate long ways, how to use it with the unit circle, but if you have it memorized, you don't really need to do all that. I'm just showing how the unit circle was used and why we can get the values we do. It is over 1:30, but I'm fine with staying longer if you want. It's up to you. You can leave at any time. Let's see. Most of this is kind of memorization for the unit circle. Like I said. Okay, see ya, Tani. So if you let me know what specific part that you want steps for, then I can try and help you. It's just all this stuff, I spent a good 15 minutes going over how the unit circle is derived, but you don't really need to do that to do these problems. Do you understand what I'm saying? As long as you have it memorized, you don't need to do those steps again. But if you tell me the specific part that you want steps for, I can certainly write steps for those. I mean, to solve integrals, that specific problem, okay, solving integrals, right? You first need to how do I put this? Turn function into solvable form, or, you know, simplify maybe. Find antiderivative. And that finding antiderivative can be, you know, from one of several rules that you use. And 3 is evaluate at both bounds, right? And our bounds in this case was 3 pi over 4 and pi over 4. Subtract lower from upper bound. I mean, that's just solving integrals in general. An example of step 1, you know, turning function into a solvable form, we had 2 secant squared, right? We had 2 secant squared. Well, I took the 2 out, right? I took the 2 out of the integral so that I only had secant squared by itself. And so that's an example of doing step 1. You simplify or use rules of integrals to turn the function into something that we know the antiderivative of. And once you're able to find the integral, it's pretty simple to plug in both bounds. As far as the other stuff I went over, it's kind of memorizing that cosecant is the opposite of sine, secant's the opposite of cosine, cotangent's the opposite of tangent, tangent's equal to sine over cosine. It's just memorization, to be honest. Memorizing that the antiderivative of secant squared is tangent, antiderivative of negative cosecant, cotangent's cosecant. Everything else is kind of memorization, but I just kind of went over how we get those answers. Are we good to go, Alfonso, or did you want me to go over something else? Or, I mean, I've got a bit of time, so it doesn't have to end at 1:30. Javi, you good to go? I see a thumbs up.
Yeah.
Okay, great.
All right.
I'm glad
thanks
you
for
found
this.
it really helpful, Javi. He really made me happy when you said that. Okay, I'm gonna stop sharing and